Hello students, how are you? I hope you are all fine. Today we are going to learn a topic electrical field on equatorial axis of electrical dipole. What is the electrical dipole here? Electrical dipole actually is a system which includes equal and opposite charges separated by a small distance. So here also we have two charges plus q and minus q separated by a distance to a. So the equatorial axis located at distance a from minus q, also from plus q it is located at a. We have drawn this axis, equatorial axis. Point P is the point where we have to find out electrical field. Okay. Now join this point P one by one line to minus q, by one line to plus q. This line makes an angle theta with this horizontal line. Okay. The horizontal line is the line which are joining center to center of this minus q to plus q, which is a straight line. Okay. Now this point is at a distance r from the point O. This distance is a. This angle is 90 degree. So by using a Pythagoras theorem, here we can write this distance from P to minus Q is under root R square plus A square. Similarly, from plus Q to point P is also at a distance under root R square plus A square. Okay. Now we have to understand that we are dealing with this electrical dipole. What is the electrical dipole? We already explained the system containing plus q and minus q charge separated by distance 2a. So what is the electrical dipole moment? We have to consider one charge. Suppose this is a charge plus q, and what is the distance this plus q charge from minus q is? It's a 2a. So product of this plus qa with this 2a, okay, the distance between these two charges is the 2a, and the product of this plus qa into 2a gives us the electrical dipole moment. And the direction of this electrical dipole moment is always from negative charge towards to the positive charge. So here we have written p and we have shown the direction. Okay. Now we also know that the electrical field, because of the point charge along a line or at a distance, suppose L, we can write K, it's constant 1 upon 4 pi epsilon into Q upon L square. Here the L square is under root R square plus A square for both the charges. Okay, for the both the charges. So here the square root and square get cancelled. We can write kq upon r square plus a square, where this a is much smaller than the r. Here the a is much smaller than the r. So because we have to use this concept in this derivation. Okay. Now because of this plus q, the electrical field at P, okay, is plus E, which act away along this line q to p line, okay, and act away from the charge plus q, act away from this charge. Okay, so its direction is along this line and away from this plus q charge. Okay, this line also makes angle theta. Here is this angle theta. So obviously here if you draw one horizontal, this angle is also theta. Okay, now this plus e making a angle theta with the horizontal. So we have to divide this, or we have to write its two component, right? Plus e sine theta in vertical direction and plus e cos theta in horizontal direction. Similarly, for this minus q also, okay, minus q also, we have to resolve the electrical field at point P. Okay, the because of the minus q, the electrical field E act along the line minus q to p, but towards the minus q. Okay, that means like this in a downward direction. Okay, like this in the downward direction. Okay, now this minus e also we have to resolve into two components, like this minus e sine theta, also here minus e cos theta. Okay. We can observe here this plus e sine theta minus e sine theta acting opposite to each other and will get cancelled. Okay, will nullify to each other. But here with horizontal component, we can observe both have the same direction. Both have the same direction, so we can make addition here. E cos theta plus e cos theta, it will gives you 2e cos theta. Okay, so we have written here E net is equal to 2e cos theta, and we are already seeing this formula kq upon r square plus a square. Now, question is about this cos theta, so we can find out this cos theta from this diagram. Okay, so what is cos theta? Adjacent side upon the hypotenuse. Okay, adjacent side upon the hypotenuse. So we can write a upon under root r square plus a square. Okay, r square plus a square. Now, as we discussed, a is much smaller than r. We can neglect this a here. We can neglect the a here. Now, this r square have the power here 1, needed this a square, so r square have the power 1. Here the r square have the power 1 by 2, so 1 plus 1 by 2 gives you 3 by 2. Okay, again I am repeating, this r square have the power 1 here, and this r square have it is under square root, so we can write 1 by 2. So 1 plus 1 by 2 gives you 3 by 2, r square raised to 3 by 2. This square and this 1 by 2 get cancelled, and here we are finding in denominator r cube is remaining. So we can write E is equal to kp upon r cube, and this is a formula to find out the electrical field on equatorial axis because of this dipole. Okay, because of this dipole. Okay, I hope you are getting. Thank you very much.